Kia ora Year 12. This question has got some differentiation sneaked in and then some integration. So remember when I talked about differential equations the very first day that I did that, and I said that one of the things you could be asked to do was to verify that something was a solution to a DE. Well, that's basically what this first question is, and it's one of the easier questions in the whole paper. So we're given a function, y is equal to this, and we're asked to find dy by dx. And that's going to be the product rule, and then we have to show that this thing here is true. Okay, so the two steps we're going to do in here first we're going to find dy by dx, then we're going to find d squared y by dx squared, and then we're going to substitute this and y into here and show that it equals 0. And the second part is a pretty straightforward integration question, really. We've got to find the exact value of the area of the region here. So we're given the limits of integration, which makes it much easier, and we have to get on with it and integrate that. And so this will be an integration by parts question, but we'll look at why that is later on. Okay, so doing this, I'm going to do this reasonably quickly because I don't think it's as hard as some of the other things we did today. So we've got this, so we've clearly got a product, right? So we've got this times this. If you're still writing it out as u and v, then you can do that. Remember, we want uv dash plus u dash v. Most of you, though, will probably just be getting on with it by now. So dy by dx is equal to x, so the first function, times the derivative of this. So we've got to chain rule it. So negative a half sine of a half x, and then the other way around. So the derivative of this one, 1 times the second function, cos of a half x. And I think that was worth quite a generous 2 marks. So putting that together, we get, let's see, negative x over 2 sine of a half x plus cos of a half x. So the second derivative is going to need me to do the product rule again. I'm going to have this one times the derivative of this one. So this will give me 1/2 cos of a half x. So you'll see by now that your chain rule skills have got to be completely automatic to be able to do these questions, right? So that's the first bit done. Plus, swap it around, and we're going to have the derivative of this, so negative a half times this function here, times sine of a half x. And now I have to differentiate this bit, so this is going to be plus negative 1/2 sine of 1/2 x. Just get rid of that plus sign. Okay, let's clean that up and collect up like terms. So we've got negative x over 4 cos of a half x, and then I've got minus a half sine half x minus another half, so it's minus sine of a half x. Looking at the dE, we need to have 4d squared y by dx squared, so we might as well do that now. So 4d squared y by dx squared will be negative x cos of a half x minus 4 sine of a half x. Right, so getting on to part 2, we're going to write down the left-hand side first, which is 4 times d, so left-hand side, just like when we're doing a trig proof, right? And now we're going to substitute, and we're just about done when we do it, right? So we get negative x cos of a half x minus 4 sine of a half x plus y, right? Well, y was x cos of a half x, and then that's meant to be not plus 4 sine of a half x. And looking at that, we've got this and this, and we've got this and this, so the whole thing equals 0 as required. So pretty straightforward 4 marks, I reckon. If you're having trouble with that, you probably need to go over your trig derivatives. That'll be back in chapter 4, and your trig integrals will also help you support that. That's in chapter 8c, and you also need to make sure you've got chain rule down from AS. Okay, the second question is where we're going to integrate and find the area under the curve. So for that one there, we're doing this. We've got the integral between pi and 0 of this. So looking at this, we don't have the nice pattern where we've got the derivative of this thing sitting out there. we've got two functions of x. So this looks like if we were differentiating, it would be the product rule, which often means that we're going to be doing integration by parts. We'll just put the x back in. We have to decide what we integrate and what we leave. If I integrate this, it's going to get worse, so this is what I want to leave. And integrating this is going to be just fine. So we're going to integrate that both times, and then we're going to differentiate that on the second go through. Okay, so let's get on with it. We're going to leave the x, and we're going to integrate this. It will give me, so I have sine of a half x, and I need to have times 2, right, to undo the half that comes out when I chain rule. That's evaluated here between pi and 0 minus this integral. Right, this time we're going to differentiate this, and we'll get 1. And again, we integrate this, so it's 1 times 2 sine of a half x dx. I can do this in 2 bits, or I can shove it all together. I think I'll do it all together. So we're going to have 2x sine of a half x, right, minus, let's leave a gap for the coefficient here. It's going to be cos of a half x. So cos differentiates to give me negative sine, which is what I want here. So that's going to be a plus. I want to end up with a 2. I'm going to get a half chucked out here. So it's going to be 2 times the reciprocal of this. So 2 times 2, cos of a half x. And before we go any further, we're going to check that that coefficient works, because it's really easy to get it wrong. So looking at this, when I differentiate cos of a half x, it's going to give me negative 1/2 sine of x, sine of a half x. And we want to end up with this. We want to end up with 2. So we need to times through by an extra 2. So that looks good. Let's just get on with substituting in without fixing that. That gives me 2 pi times sine of pi on 2. So just thinking about our trig functions here, which really help us. That's sine of pi on 2 plus 4 cos of pi on 2 minus 0 in here plus 4 cos of 0. So sine of pi on 2 is 1, so it's going to be 2 pi plus, this is 0, minus 0, minus 4. So my final answer, and it's a nice exact value, is going to be 2 pi take away 4. Right, so there you go. That's that question all done. That leaves me with one differential equation one to do, and I'm not going to do it tonight. So I will throw that up on YouTube sometime during the day tomorrow. Thanks for watching, and let me know if you've got any questions left about this one.